Okay, welcome to this episode of Mage to Kata. I apologize, this episode is a little bit longer, but I decided to do it nevertheless because I think the steps are actually quite important. Also, sorry for this much noise here. I'm forced to record the intro right now because I'm running out of time. Tomorrow the video is due and I want to finish it tonight. So, for this kata, I actually did something a little bit different. Well, actually, I just wanted to make it shorter. So I didn't refactor all the way that I would usually refactor the code, and I didn't do the steps as small and granular as I would usually do it when I would be doing the project, for example, in real work situation. So for now, I pose the challenge to you: find a better way of doing things. Refactor further. Do smaller steps during TDD. And yeah, find better way to do it than I do. Hope you enjoy it. As always, thank you so much for tuning in. I really appreciate it. I really would like to hear your feedback. So let me know what you think. Enjoy! This kata is about creating an action controller using TDD. We will use unit tests to step-by-step flesh out the behavior of this simple action controller, and we will use mocks to design the way it interacts with the business logic layer of the application. I already have created the module by following the steps of the module config kata and the route config kata. So the route already exists and is correctly configured, and the skeleton action controller class here is ready to go. Let's define our goals for the action controller TDD kata. We don't want to put any business logic directly into the action controller, because that would couple our business logic to the delivery mechanism, namely the web. The business application should be independent of the web. So the action controller simply is an entry point into the application. All the action controller should do is convert the request data into a format that is independent of HTTP and pass it on to the next application layer. This independent format could be a data transfer object, for example, but for the kata we will use a simple PHP array. I try to avoid arrays for more complex scenarios, but for today it will serve. Beyond dealing with input arguments, action controllers may also do some error handling, or they may initiate some further routing. So for the purpose of this kata, let's assume the controller will validate a given request is a post request. And if it is, it will pass that request parameters to an application layer, and that will do the actual processing. In case of an incomplete request, we want to return an appropriate error result, so if some parameters are missing, for example. Otherwise, if the process doesn't throw an exception, we want to redirect the visitor to the home page. So what we'll be doing is some request validation, some delegation, and some error handling. Pretty standard stuff for an action controller. So let's start, of course, by first creating a test in the directory unit controller index. So these two directories match these two directories, and now we'll create a new test, index test. Extends PHP unit framework test case. I'll add a test nothing test first, just to check everything is okay. Okay, here's the expected failure. Good. So, what should we write as the first test? Well, given this skeleton class here, maybe a good first test is to check for the return type of execute. So, let's say test, it returns a result instance. This assert instance of, let's pick the right result interface, and that should be this controller execute. So you can see I'm referring to a property here that doesn't exist yet, and of course that fails, but sometimes I like writing the assertion first because that then leads me to building the test that allows me to successfully execute that assertion. I want a setup method where we can initialize the property controller. I'm using new index because the namespace in our test matches the namespace in our controller class. Alright, that takes care of that property. We can see now PHP-Storm knows the execute method exists, but now something is wrong here. We're missing a required constructor argument to app_action. That's the class we inherit from. Let's have a look what that constructor looks like. It takes this context instance. I'll copy that as a reference. And in the test, let's create a mock of that. Get mock. Turn off the constructor and pass that into the action constructor. And good! Now the test is failing for the right reason, because we're just returning nothing. Before we continue, I want to import this class and alias it as action context. Okay, still failing for the same reason. Now, in order to return a result interface here, we need some kind of factory to create that result instance. The question is, what type of result should we use? In real work, that question rarely comes up. It tends to be obvious. But for the Kata, we are mainly interested in setting the right HTTP response codes. So let's use the most generic result type, the raw result. So we need to add a dependency on raw result factory, and when create is called, it should return the raw result. Let's start by mocking the raw result instance. Get mock. There only is a single class called raw in Magento 2, which makes the import easy. However, I want to alias it to raw result. That's nicer. Add that as a property. And also a PHP unit mock object. Okay, now we have the raw result, but we don't want to inject that directly into our action. We want to inject a raw result factory. So let's create a mock raw result factory. Get mock raw factory. Oh, look at that, it even exists. Most factories don't exist at time of mocking because they're auto-generated. But should this be a generated class, it might be deleted in future, so I like adding the create method to the mock specification. That way this test works even if the factory is deleted. Time to alias the factory just like the result class. And whenever the create method is called, we want the factory to return this mock result. Right, and now we can pass this factory as an argument to the action constructor. The test's still failing for the same reason, but now we can actually implement the code to make it pass. So let's override the constructor, add the raw factory as a dependency. Oh, let's keep things consistent. Raw result factory. Initialize that field, and now we can return this raw result factory create. And we're green. Very good. Nothing to refactor here. What about this? It's still in pretty good shape. So, what next? Well, a lot of the behavior of our action controller revolves around the request method. For example, whether it's a post request or a get request. So probably it would be handy to be able to specify the request method in our tests. For this, we need the request. Get mock. And we can't use the request interface, which would be perfect, because it's too incomplete. There aren't all required methods on it, so we'll just use this request class here, and I want to alias that as HTTP request. That's good enough. So let's add that as a field. And so this request is actually already being passed as a dependency to our action controller as part of the context. So if we look at the abstract action here, that request is already part of the context. And this request property here is returned. Oh, yeah, that's too many. Through this public function getRequest. So we can use that method inside of our class to get to the request. The only thing we have to do is we have to ensure that our mock context getRequest returns our mock request. So, still green. Now we have a request object, we can specify the request method. So let's do mock request method get method will return post, for example. So this little addition doesn't allow us to write production code, the test doesn't fail, but now we are in good shape to write the next test, which is a test that ensures we return a 405 method not allowed result in case the request is anything but a post. So test returns 405 method not allowed for non-post requests. So let's see. We definitely should start by specifying a non-post request method. Alright, let's see. So if it's a non-post request method, I expect this mock raw result method set HTTP response code with 405. And of course, we also want to call this controller execute. So yeah, that's the test. Still green. Oh, wait a moment. We expect the method to be called once. Okay, good. So now, how can we make this pass? Let's fake it till we make it. Let's extract that into a variable like so. And now we can call result set HTTP response code 405, and we're green. Anything to refactor in the test? No, it actually looks pretty good. But here in the action class, let's extract this into a method that reveals a bit more about the intention of the code. Get method not allowed result. Okay. Oh, PHP Storm added the type hint. Let's import that. And alias that matching the factory as raw result. Okay, so currently execute just always returns the method not allowed result, and we're still green. Good. Time for the next test. For the next test, let's do another degenerate test case, so not the happy path. Let's say we test what happens if not all required arguments are present. So it's the controller's job to take the request parameters from the request and pass them on to the application layer in some delivery mechanism independent format. The business logic should know nothing about the web. We'll just use an associative PHP array to pass on the arguments. In a more complex scenario, I try to avoid PHP arrays and prefer data transfer object with built-in validation, but for now this will do fine. So we'll just pass $request getParams to the useCase class method. And should there be something wrong with the parameters array, for example, if a required argument is missing, that useCase class should throw an exception. So in order to build this behavior, we need to add the useCase class to our controller. So let's go back to our setup method. This mock useCase is this getMock. As I said earlier, useCase is just a non-existent dummy class. And since this is a non-existent class, we'll have to add the method name, do something that's good enough. Let's add the mock useCase field declaration to the test class. Okay, now time for a new test. Test returns 400 bad request if required arguments are missing. Right, so let's say we have a post request. Let's also say this mock request method getParams will return an empty array. So some arguments are missing. Actually, let's make that a bit more expressive by extracting that into a variable incomplete arguments. Right. So if this happens, I want to set an expectation for the HTTP response code 400. Okay, this test would already fail, but there's one more thing I want to specify before we run it. This mock use case method do something with incomplete arguments. So this is expected to be called once. Okay, so this fails. Because, well, right now we're still returning our method not allowed result. I want to start by surrounding this line with an if condition so we can check for the request method. Unfortunately, get method is unknown because get request is type hinted to return request interface, which doesn't contain the method. Okay, this split flow here should take care of our existing tests for the invalid request methods. Now we can focus on adding the new functionality. First, we need to add the use case class to the constructor arguments. Oops, wrong one. We want the use case. Did we already add that to the constructor arguments in the test? Oh no, we didn't. Okay, and now we can do the following. This use case do something with this request getParams. All right. Whoa, 2 tests are failing. What's going on? Well, we're not returning anything, so the first test fails, and our last test also expects a return value. So to make the test green, we'll have to return our bad method call result. And now we're back to green. So, is there some more to refactor here? Let's see. Let's take this here and extract it into a more descriptive method. Let's call this getBadRequestResult. What about the test? Anything to change here? I think it's okay. Okay, so what's the next step? Oh, I know. We're not even throwing the exception yet. Okay. So let's say if incomplete arguments are passed, we want the use case to throw an exception. Will throw exception. New required argument missing exception. And I've made a habit of always adding a message to exceptions, even if it's just a test exception like this one. Now do something will throw this exception. Rerunning the test fails because the exception doesn't exist, so let's create it. And I think it's a good idea to add it under the model directory in this module, because the exception is thrown by the use case, and the use case is part of the application layer, which often resides under the model namespace. I like adding an exception subnamespace and add the class in there. And it extends the runtime exception. Okay, now we can import the exception class. And as expected, the test fails because the exception is thrown and not caught. So now we can deal with the situation where something goes wrong in our action class. So let's take all of this and wrap it in a try catch block. Required argument missing exception. So now in this catch block, we want to return this getBadRequestResult. Let's run the tests. Our first test fails again. The reason is it expects a result interface to be returned, but currently, if nothing goes wrong, we don't return anything. So for now, just to temporarily keep everything green, let's return a raw result instance. And we're back to green. Good. All green means time to refactor, if needed. Anything to refactor? What about this? Let's see. Let's change this a bit. Everything still green? Okay, and now I can take this and move it into a method. Is post request. So this now is if not is post request. Still green? Yep. Okay, and now we can take this into its own method and let's call it process request and redirect. The and redirect part, that's something we still have to do, but let's call it that already anyway. And maybe you already know what I'm aiming for here. It's a simple if-else branch, so we can use a nice ternary operator. So we've got, if it is not a post request, return get method not allowed result, otherwise process request and redirect. This method is important. I'd like to move it up a bit. So in process request and redirect, we try to do something and return something. This is currently still a placeholder raw result. It'll be a redirect result shortly. Otherwise, if arguments are missing, we return a bad request result. And down here we have the utility methods to create the result objects and is post request. Okay, that's not too bad. So let's move on to the final test. Test redirect to homepage if request was processed. Okay, so how would that look? Well, let's say we have a post request and we have some query parameters. Foo ID 123, I don't care, it's just for documentation. And finally, we should assert that a redirect result is returned. But we haven't got a redirect result yet. So let's add it as a dependency, starting with a mock in the setup method. This mock redirect result is this getMock redirect class and disable the constructor. I'll start with the regular redirect class name and import it, this one, and now I'll alias it as redirect result. Initialize the property. And can you believe it? This is our final mock. Next, let's create a factory for that. Redirect factory. Ah, look at that. It also exists, just like the raw result factory. But again, because it's a factory, I don't want to rely on its existence, so I'll add the create method here. So if the factory's create method is called, it will return the mock redirect instance. Okay, now we've got another properly mocked factory. Now we just have to add it as a dependency, and just like the request, this actually already is being passed into the action as part of the context. We can see here that it's required by the abstract action that we inherit from. However, in this case, different from the request, we don't get a nice getter method to access the property. GetRequest has this getter method, but for the redirect result factory, there's just this protected property. A protected property isn't really like a class interface. That's nothing I want to rely on from a class I inherit from. Protected properties exhibit the same smells as global variables. They violate the principles of encapsulation, so we're not going to use that. Instead, we're going to assign it to a private property of our class. And to do that, we have to first add it to the mock context. So now here we can say this assert same, this mock redirect result, And that's the same as this controller execute. Okay, finally the new test fails. We can complete our action. First, in the constructor, let's assign the new factory to a property. This redirect result factory is context get redirect result factory. Add field, import the class, alias it to keep things consistent. Alright, and now here we simply have to return this redirect result factory create. Well, not quite done yet. Let's see, we must be doing something wrong here. Mock redirect result factory. Ah, yes, right here. We don't want to return the redirect result, we want to return the redirect result factory. And now we're green. Alright, almost done. But there's one last step, because we haven't yet specified where we want to redirect a visitor to. So let's expect this mock redirect result, this once method setPath to be called. And we're back to red, since we're not calling that method anywhere. Now let's go ahead and extract that into a variable and call setPath homepage. And we're green. Okay, functionality-wise we're complete. However, I want to take this into its own method, get redirect to homepage result, just to keep with our convention here, to create the result instances in their own dedicated methods. This looks okay. This looks kind of okay. Import this. Alias that as redirect result. All right. And here we no longer have just a raw result, we have this also. Everything's still green, okay. Very good, and this completes the kata. Quite a bit of mocking going on, but well, each class we instantiate requires a factory, so that's 2 dependencies plus the context dependency we inherit. But I still hope it's clear what we're doing. The test itself actually read quite well. And this first test we actually can now get rid of because all the cases it tests are already covered also by the other tests. Good. Time to wrap up. I hope you enjoyed it. Please give the episode a thumbs up if you liked it, and please leave me a comment under the video or reach out on Twitter. As the final step, as always, please go ahead and delete all the code so we can do the kata again. Thanks for following, and until next time.